Okay, Gport Limited has an ordinary share capital, 10 quarter par value. This is the par value of the shares. Okay, when the shares were issued, this is how much they were going for, of 800,000 kwacha. So, ordinary share capital, colleagues, this is the money you raise from selling shares. And average annual profits after taxation of 500,000 kwacha. Gport paid a dividend of 250,000 this year. The current return to shareholders of companies in the same industry as Gport is 12%. Okay. Although it is expected that an additional risk premium of 2% will be applicable to Gport. Now, every majority of you were present yesterday. What is this additional risk premium? Majority was present yesterday when we talked about this additional risk premium. And Madam Yvonne, you can't say it was lunchtime yesterday. Okay, it wasn't lunchtime. Mm, please try. Mhm. Thank you, Madam Labot. You've been paying attention. Wonderful. Yes, additional risk premium. This is the extra return for taking on a risk. The risk is investing in Gport Limited. Okay. Since Gport Limited is a small company and unquoted company, okay, so there's an extra risk when you invest in it. So that's why they put this additional 2% risk premium. Colleagues, are we okay with that? I hope I wasn't too far. It's not on this. It's not on the. Is it Lusaka Securities Exchange? It's not in the stock market. Mhm. Yes, the average sector price earnings ratio is $12. Colleagues, in financial accounts, when we did financial ratios, what do you say the price to earnings ratio is? Mhm. Price to earnings ratio, what does that tell us? The price to earnings ratio, that was in financial accounting ratio analysis. Mm. So that's parallel. Ha! Ha! That is parallel. Ha! If you use the AI, please unsubscribe from that AI if you are using AI. That is parallel. Ha! Partners. Ha! Yes, Madam Kat. The share Okay. We need to spice that up. Okay. But thank you for your attempt. Yes, Mr. Chimunya. Colleagues, I think we need to clap for Mr. Chimunya. Okay. Because, colleagues, this was in first. Let's wonderful, Mr. Chimunya. Wonderful. Wonderful. Yes. How much investors are willing Yes, how much investors are willing to pay for every one quarter earning of the company. Okay. So a high PE ratio means investors are confident in your company. Okay, they're willing to pay more just to earn a one quarter from your company. Yes. Okay. So now they're asking us here, compute the expected valuation of GPOT if. So here we're going to value GPOT using the dividend discount model. All right. So I said you'll be given three scenarios. All right. Scenario A, no growth rate in the dividends. Okay. So scenario A, the current level of dividend is expected to continue into the foreseeable future, meaning every year you're going to be paying 250,000 as dividends every year. So now we need to get the present value of this perpetuity because it's into the foreseeable future. So we don't know when it's ending. Okay. So we need to get the present value of this perpetuity of 250,000, which will be paid every year. So you use this formula here, colleagues. Okay, the value of the company, okay, DO, dividend paid, divided by required rate of return. Okay, remember the required rate of return, we added this 2% additional risk premium to the existing required return of 12%. We got 14%. Okay, so the required rate of return, you put it as a decimal 0.14. The dividend that has been paid, 250,000. Okay, so 250,000 divided by 0.14, we're going to get, let's have our calculator so that we confirm, colleagues, all right? 1,785,714.28. That is the value of GPOT using the no growth model. Any questions? Any questions? Madam Lavette, Madam Juanita, Madam Alinawen, Mr. Dennis, Mr. Boniface. Okay, wonderful colleagues. So this is the value of G pot. We go to scenario 2. Where the dividend is expected to grow at a rate of 4% per annum into the foreseeable future. Okay, so this dividend is going to be growing at 4% every year into the future. Okay, so this is when you're dealing with constant growth, where the growth rate is the same forever. Okay. So when you just see one growth rate, okay, then you're going to use this one, the constant growth rate. Okay, so this is the formula you're going to have. Okay, the value of the company equals D1, next year's expected dividend, over the required rate of return, R, minus the growth rate, G. So this D1, which is next year's expected dividend, the formula is DO, the current dividend or the dividend paid, multiplied by the growth factor, which is 1 plus G. Okay. Remember, we're saying this dividend is going to grow by 4%. Okay, so here basically in the numerator, we're asking if this 250,000 grows by 4%, how much will it be? Okay, so DO 250,000. Okay, growth rate 4%. That's why I put it as 0.04 here. Okay, so 1 plus 0.04, you get 1.04. Okay, 1.04 times 250,000, 260,000. Okay, when that 250,000 increases by 4%, it becomes 260,000. Okay, in the denominator, our required rate of return 0.14 minus our growth rate 0.04, we get 0.1. Okay, so 260,000 divided by 0.1, you get 2,600,000. Any questions on this one? Mr. Kasono, any questions? Mr. Tuambo, any questions? Mr. Emmanuel, any questions? Madam Kathy, any questions? Okay, don't worry, the recording is coming. As soon as we finish, the recording is coming. Okay, part C. The dividend is expected to grow at a 3% rate for 3 years and 2% afterwards. Okay, colleagues. So, here now we've seen, so whenever you see two or more growth rates, okay, then here now the multi-stage growth model. Okay, when you see two or more growth rates, okay, so here you can do this in 3 steps. Okay, whenever you're dealing with the multi-stage growth of dividends, okay, you do it into 2 steps. Step 1, okay, calculate the expected dividend and the terminal value. Okay, the terminal value just represents the dividends that will be paid for when the growth rate just remains at 1% forever. Okay, once the growth rate goes down to 2% and stays at 2% forever, All those dividends that will be paid are represented by this terminal value here. Okay. So we need first calculate the expected dividends using this formula here. Okay. The dividend multiplied by the growth rate. Okay. So we're using the 3% growth rate. Okay. So it's expected dividend for year one. Okay. So we're going to say D1 equals DO 1 plus G. DO is this 250,000. The growth rate is 3%. Okay, that's why we put 0.03. So 0.03 plus 1, 1.03. 1.03 times 250,000, we get 257,500. So the expected dividend for year one is going to be 257,500. Okay. Expected dividend for year two okay, we're going to say D2 equals D1, 1 plus the growth rate. Okay, so remember our D1 is this 257,500. We're just saying this 257,500 is going to grow by 3% again. So when this 257,500 grows by 3% again, the, the expected dividend for year two is 265,225. Are we clear up to this point? Any questions so far? Okay. Expected dividend for year three. Okay. D3 equals D2 1 plus G. Okay. So this 265,225 is growing by another 3%. Okay. So when this 265,225 grows by 3%, becomes 273,181.75. Okay. Then now this is where the growth rate changes to 2%. Okay. Now, colleagues, it wouldn't be practical to start calculating, okay, expected dividend for year four at 2%, year five at 2%, year six at 2%, because you don't know where you're going to end. This is into the foreseeable future. Okay. So if you try to continue with this same process, you get tired because the foreseeable future might be 100 years. Would you like to calculate expected dividends for 100 years doing this process? Nobody would like to do that. It would be too long. Okay. That's why this terminal value is coming in. It's representing all those dividends that are going to be paid at the 2% there. Okay, which are going to be in the foreseeable future. Okay, all those dividends at 2% that are going to be paid in the foreseeable future are being represented by the terminal value. Any questions before I calculate this terminal value? That's what the terminal value is representing, okay? The value of all the dividends from the point when the constant growth begins onwards. And the constant growth is at 2%. Okay. So this terminal value is just similar like the previous one we were looking at, the constant growth formula, that one. Okay. We're just using the same formula here. Okay. So your terminal value, okay, we say next year's expected dividend, okay, which is D3 multiplied by 1 plus the growth rate over the required rate of return minus the growth rate. Okay. So D3 is 273,181.75 multiplied by 1 plus 0.02. The growth rate is at 2%. That's why we're using 0.02 over 0.14, which is the required rate of return, which was 14%, minus the growth rate of 0.02, which is 2%. So you're going to say 273,181.75 multiplied by 1.02. Colleagues, I hope we've got calculators so that those who just be copying figures, they shouldn't be penalized. They should at least copy the correct ones, not wrong figures. Okay, so 278,654.39. You're getting the expected dividend for year four. Remember, we're just hold on. Remember, madam, we're just using this same formula here. Next year's expected dividend, since we're in year three, so next year's expected dividend is for year four. Okay. But basically, we're using this same formula here. Yes, someone else wanted to ask a question? No. You only use this formula once the constant growth starts. Okay. Which is 2% in this case. So don't use it in year two. No, madam. This formula to use it in year two, no. Okay. Only use it when the growth remains the same forever. The growth rate now stays the same forever. So you use it. Is that okay, madam? So 3 years. Yes, yes. Because our timeline is 3 years. Maybe we should see this with a number, the number line here. So we're here in year zero. Dividend for year one, year two, year three. So after year three, okay, that's when the growth rate now stays fixed forever. That's when you are going to apply this terminal value, madam. Okay. So you always have to take note of the timeline in the question. Okay. Take note. So here we know that for 3 years it's going to be at 3%. Then it will change to 2% and remain at 2% forever. So at that point where it remains 2% forever, then you calculate the value of those dividends when it's at, 2% forever. Yes, they get even they might even give you, more than three growth rates. Yes, until you reach the point where the growth rate remains the same forever. So you do this process here of these expected dividends. Okay, for example, if it changed to 2% for 2 years, would have done this same process for the next 2 years. Then after those 2 years, if the rate now stays the same forever, that's where now you apply the terminal value, which represents all the dividends when the growth rate stays the same forever. And in this case, it is 2,322,119.91. Okay. This is the value of all the dividends that are going to be paid when the growth rate is at 2%. Any questions before we move further? Mm-hmm. Um, that's what we're going to do next. These dividends, because all of this is money that will be paid out in the future. So all these dividends now are going to discount them into today's value. Okay, today's value year zero. The dividend for year one, you discount it into today's value. The dividend for year two, you discount to today's value. The dividend for year three in today's value, and also the terminal value, discount it into today's value. So we're going to get the present values of all of these. Okay. Okay. So remember the formula for present value. Present value equals future value, which is in this case the future values are those expected dividends. Okay. Those expected dividends. Okay. So the expect and the discount rate, colleagues. Okay. Remember that what are we going to use as the discount rate? I mentioned this yesterday. Someone who heard. What are we going to use as our discount rate? 14%. Yes, yes. The required rate of return. Please do not use that growth rate of 2% as a discount rate. Yeah? Your lecturer will personally call you and be disappointed with you for doing that. So yes, future value multiplied by 1 plus r to the power negative t. Okay, so this 257,500, an expected dividend for year one. In today's value, okay, so you say 2,575,500 multiplied by 1.14, the power negative 1. Colleagues, get your calculators so that you make sure that we are getting similar values. Okay. This 1.14 to the power negative 1 is 0.877193. Okay, so multiplied by 257,500 and you get 225,877.19. Okay. So that expected dividend for year one that will be paid at the end of year one in today's value, it's 225,877.19. Any questions before we get for the present value of D2? Okay. The expected dividend for year two, 265,225 multiplied by 1.14 to the power negative 2. Okay. Since it's the expected dividend for year two, so we'll put it to the power negative 2. Okay. 265,225 multiplied by this decimal number, you get 204,082 kwacha tungwe. Expected dividend for year 3, convert it into today's value. This 273,181.75 multiplied by 1.14 to the power negative 3, you're going to get 184,389.89. Ish, I can imagine in meetings, you're just reading these big numbers, you might get tired. That's why I see why people just say 184,389, because it's tiresome reading all these big numbers. Okay. Then the present value for the terminal value, okay, this number here, 2322119.91 multiplied by 1.14 to the power negative 3. Colleagues, notice we're discounting it to the power negative 3, not negative 4, but negative 3. Why is that, colleagues? Why are we discounting the terminal value in year 3, not in year 4? Okay. The reason why we're doing that, the assumption is that these dividends which represent all the dividends at 2%, they also be paid at the end of year 3. Okay. That is the assumption here. So we discount it to the power 3, not 4. Yeah. So this number multiplied by this decimal number, you get 1,567,361.28. Any questions before I total up these present values? Yes, the assumption is to be paid in year 3. I'm not really sure, sir. Okay, I'm not really sure. Okay, when I just checked on that, the answer I was just given is that for the terminal value, discount it in the year before the growth rate stays fixed. So maybe you can research for me, sir. Okay, can you research for me on that one, Mr. Kasson? Please research for me and the masses, okay? Yes, colleagues. So you add up all of these present values here that we've collected here. You add them all up and you get 2,181,710 kwacha 38 ingwe. That is the value of G pot.